Right, hello everyone. Welcome to this virtual induction video for maths. I hope you're all here because you're interested in studying maths with us in September. In this video, we are going to give you some information about the course, why you should study maths at Herts and Essex in September, and give you a bit of a taster lesson just so you can see what maths lessons will be like if you do decide to join us. Please watch the video, pause, rewatch it as many times as you like, and remember, if you have any questions or feedback, there is a Google form at the end that you can use to get in touch, and someone will get back to you as soon as possible. So we're going to start by introducing you to the maths team. So let me start by introducing myself. This is me on the screen. My name is Mr. Corner, and I am the subject lead or the head of maths in the sixth form here. The other maths teachers who will be teaching year 12 from September, here we have Miss Watson, here we have Mrs. Jones, this is Mrs. Appiah, this is Mr. Grant, and here we have Mr. Fafalios, who I do not have a picture of because he will be a new member of staff joining us in the department in September. Now, for those of you who've been here for 5 years, our internal candidates, all these faces will be very familiar to you. To our external candidates, I wish you a very warm welcome. Hopefully you had the opportunity to speak to one or more of us on Open Evening back in November. Now, when you join us in September, if you decide to take up maths, you will have on with your class 2 of these maths teachers. Half your lessons will be one of us, half your lessons will be with another. Okay, so in the first part of the video, you're going to now hear from some of our current and former sixth form students about their experiences of maths in the sixth form and some advice and guidance as to why you should choose it. So let's hand over to them.
For A-level I chose English literature, maths, biology and chemistry. I chose maths not for a few reasons other than I enjoyed it at GCSE. First, I thought it was a really good complement to my science subjects, and I found there was substantial crossover, especially at university level. I also thought it was quite a refreshing contrast to English, because that was an essay-based subject, and maths was more logical, problem-solving and methodical.
I do maths, further maths, chemistry and physics, and obviously being sciences, have quite a lot of maths built into the course, and being able to have a really good fundamental knowledge of the maths that you're doing in the subjects is really helpful.
I chose to study maths for A-level because I thought it'd be really facilitating for university, and I also really enjoyed it at GCSE.
It goes with my other A-level subjects well, so I do biology and chemistry, and there's a lot of maths skills in those subjects, and also there's a lot of overlap with biology and maths in the statistics stuff.
When I was doing my GCSEs, I found it really interesting on all the way maths links together.
Maths A-level is really kind of balanced subject, so you get the theory side in pure, and then you also do stats and mechanics, which you get to apply the maths into real life situations, if you see what I mean, which is like, it's nice to have a bit of balance between those. Also, A-level maths, it gives you a bit of flexibility in career choices, so you can do engineering with it, computer science, data science, become an actuary, like I've chosen to do.
I chose to study maths at Herts and Essex because the department seemed really strong and I was impressed by what I had seen on Open Evening.
When I looked around the school before deciding which sixth form to go to, I wasn't too sure what I wanted to do. But the maths teachers there are a great help and showed me how passionate they were about the subject themselves and how they wanted to help students to do so well.
I picked Herts and Essex mainly because I wanted a change from where I was, and it had a good reputation for maths and science.
During my 2 years at Herts and Essex, I found all the maths teachers being engaging. They enjoy the subject, enjoy teaching the subject, which therefore makes it more enjoyable to learn the subject.
Our class was fairly small, which allowed the teachers to get to know each student and their strengths and weaknesses, which meant that it was easy to focus on these and develop them.
My Year 13 teachers were Mr. Corner and Miss Watson. I did struggle a bit at Year 13 with the content, so I was at the maths office every lunchtime, but Mr. Corner and Miss Watson were always willing to sit me down and help me through the content, work out the answers, and they definitely believed in me a lot more than I did, which I'm very grateful for, because in the end I got the grades I needed to go to my first choice university.
They host weekly maths surgery, so if at any point you're struggling you can pop by into them and there's a teacher on hand to help you.
I also decided to stay at Herts and Essex for sixth form because It was really important to me that I knew my teachers, I felt comfortable there, I knew my friends, most of my friends were staying there, and Herts and Essex has a really great track record of getting students to the places where they want to be, and that definitely happened for me.
I chose to stay on at Herts and Essex to study maths because I already knew the maths department really well, and they're really helpful, really supportive, and they're just really enthusiastic, and you can go to them when you're struggling, and you can go to any of them. It doesn't necessarily have to be your specific teacher. They're always there to help, and if something's not working for you, they can sit down, find a solution, and just make sure you understand. So if you're struggling with anything, they're really helpful. I also really enjoy the lessons. It's a really positive and enthusiastic atmosphere. We're always doing something different, whether it's Kahoots, PowerPoints, whiteboard work. It's just really fun, and it's a really good atmosphere, as well as the teachers being very good.
Is to not give up. At the start of the year, I was really overwhelmed by it because it's a big step up from GCSE, but I would just say, just keep going, keep working hard, and then you'll get your head around it and it will get easier. And also use your teachers. They're there and they will help you with anything they need. All the maths teachers at Herts and Essex are lovely, and just ask them for help and they will help you when you need it.
Finally, some advice if you do decide to do maths A level is to focus in year 12. It's really important to understand the basics of A level maths. If you focus in year 12, then year 13 should be relatively easy for you.
I would recommend to anyone who wants to study maths at Herts and Essex that they make sure that their GCSE skills are really strong, like completing the square, factorisation and use of the quadratic formula, because you'll continue to need these skills in A-level maths.
I'd recommend that you stay on top of your work and don't do your homework the night before.
Overall, I think if you enjoy maths GCSE, you are considering going into an apprenticeship or further education that requires a maths background, you want to complement sciences, or you just want a contrast to humanities subjects, I think maths is a really valued A-level to have, and it will definitely help you with your further studies.
Right, a massive thank you to all our current and former students who contributed to that video. I really hope you found that useful and that it gave you some really interesting feedback about maths at Herts and Essex, and should hopefully help you make a really informed decision. I loved hearing from them all, and it was really positive to hear all the nice things they had to say about what they're doing since they've left Herts and Essex and why they have enjoyed maths so much. So I'm now going to hand over to Mr. Grant, who is going to talk to you about why you might be interested in choosing maths in the sixth form and what it could lead on to in terms of degrees and or careers. Now, this will summarise some of the ideas you all have heard from some of our former students as well.
First of all, I'd like to talk about our requirements for the course and just take you through some of the things that you might be aware of in terms of how it complements other subjects. So at the Herts and Essex, we ask for at least a grade 7 at GCSE. Of course, be aware that the course is highly welcomed at Russell Group universities because mathematics complements well subjects that are offered at the higher end for biology, chemistry, physics, geography, psychology, sociology, engineering, computing and economics. Be also aware that at Herts and Essex we have a track record of success. Indeed, in 2019, a significant majority of students gained A star to C, and half of the students got an A star or an A. So we're a highly academic school. We make sure you get those highly academic grades. The maths and the way that maths complements other A levels is of course well known. I would say all the sciences include mathematics, but particularly biology. And don't forget that other subjects that maybe you hadn't considered to include maths do as well. So for example, geography and psychology include quite a significant part of mathematics within them. And so doing maths at A level really help complement those subjects. These other ones here on the screen are also well worth knowing. Just be aware that maths plays a significant part in these subjects. So I want to talk now about some of the common misconceptions about mathematics. Many people always say that there's no point doing mathematics unless you want to do a STEM degree. That's not true. In fact, mathematics complements a lot of courses at university level, a range of different things and a range of different disciplines. In fact, I do remember in one of my very first interviews for a maths teaching job, somebody asked me if maths is a science or an art. And that's because there's a lot of maths in arts and a lot of maths in science. So actually it has a range of subjects that can be applied with mathematics behind it. Many people say that mathematics is male dominated. In fact, that also is not true. There's a significant proportion of students that undertake mathematics at university now that are female. It's also worth mentioning that there are a range of different careers that you can do with mathematics, and I would say mathematics forms a very strong basis for a range of different subjects later on and a range of different careers later on. In terms of the future, I would say particularly all of these are significantly well paid and will be worth looking into in a bit more deeper detail at some later stage. Mathematics is a subject that opens doors, and many people consider mathematics to be one of those key subjects that determines how intelligent and how academically minded you are. And so, having done maths behind you, people will anticipate you to be a significantly academically minded student with a good study ethos and a good ability to understand facts, details and logic. And of course, all of these particular careers have a particular leaning towards those particular skills. We have many maths alumni in school, some of whom have gone on to really good quality degrees later on at university. And here are just some of the universities that we've managed to get students onto in the last few years. And you can see some of those are mathematicians, but some of those are also business and marketing candidates and physics candidates and so on. So there's a range of different degrees here that people have gone on to from Herts and Essex, particularly at undergraduate level. And some of them have gone further still and gone on to doctorates and masters and so on. So Herts and Essex is a fantastic first step for those really high quality degrees at the really high quality universities. The skills that you gain and develop from A-level maths are very wide and varied, but include some of the following things. Particularly in the first year, we'll spend a lot of time talking about mathematical modelling, and that's the idea of using mathematics to model real life circumstances, particularly within the area of mechanics. You'll see a lot of that going on and understand how mathematics can be used to model real life situations. Also within statistics, you'll see the use of mathematics to model real life hypothesis testing and understand what hypothesis testing means. I would also point out that in terms of communication, mathematics forms a fundamental part of how people can communicate across different countries, but in the same language, because mathematics is the universal language. That's it from me now, and I'll hand over to the next teacher who'll bring you through the next slides.
Right, a big thank you to Mr. Grant for leading that section and talking to you about why you should do maths and seeing where it could take you in terms of degrees and or careers. I hope you found that useful. I'm now going to pass over to Mrs. Jones, who's going to talk to you about what you'll actually be studying in the section and give you a bit of an overview of the course and our expectations of you in Year 12. So here is Mrs. Jones.
Hi guys, so I'm Mrs. Jones and I'm just going to talk you through the course overview and a few bits and pieces that we are expecting from you. So first of all, you will have two teachers. And this is going to be the case for everybody, so that lessons are split. Okay, so one teacher will teach pure and statistics. So the pure material is always split half and half between the two teachers, but then one will always teach the statistics and one will teach all of the mechanics. It just helps to keep those subjects a little bit separate. Okay. The course is split 2/3 pure maths, 1/6 statistics and 1/6 mechanics. That is how your grade is created as well. So you must be really strong on the pure to keep your grade up. Okay, we follow the Edexcel exam board, and that means that for that you have 2 pure papers and then 1 paper which is applied, and that is then half statistics and half mechanics. So hopefully you can see how those fractions that we were just talking about come out of those papers. Okay, so your pure maths topics you are listed there. You can read them for yourself, I'm sure. You may notice that there are a few topics there that you recognise from GCSE. So hopefully in your packs that you've had over the summer, that will help you to prepare yourself for some of those topics. Statistics topics. Okay, again, there's a few topics that you might recognise. Some of those, it will come from the packs that you have over the summer, but equally, we will build on those as well. And then your mechanics topics. So anyone that's kind of hot on their physics, you may notice or recognise some of those topics as well. Okay, so the next thing is all about the start. And really, the big thing for us is when you start, you really must make sure that you put the effort in. Unfortunately, a lot of people think that they can just kind of breeze up at the start and then sort of slowly put the effort in when it gets a bit harder. I'm afraid it's hard right from the start for an A level in maths. So our expectations for you are to attend all lessons with a positive mindset. So that means you're turning up on time, ready to go, and with the work done that needs to be done in time for that lesson. So obviously completing all classwork and homework tasks to the best of your ability, and that includes seeking advice from any of the maths teachers outside of lessons. If you have, for example, myself and Mr. Corner as your maths teachers, that does not mean that you can't ask somebody else, such as Miss Watson, for help outside. Okay, we're all very happy to help any students. Okay, do make sure that you use your study periods to go over lesson content. You will be told to do roughly about an hour's work for each lesson that you have in sixth form, and it really does make a difference for your maths. Okay, do make sure you've worked through those transition packs before September. It will help with those topics that we've just been talking about. And finally, as I've said before, working hard from day one, it really does make a difference. If you fall behind at the beginning, it's really difficult to catch up. Okay, so I hope you enjoy your lesson, and I look forward to meeting you all in September. Thanks, guys. Bye.
Right, thank you to Mrs. Jones for leading that bit of our lesson. I hope you're now feeling really well informed about what you'll be studying and what you'll get out of joining the sixth form here. So the final part of our video is going to be our virtual lesson, which Miss Watson is going to lead. So please grab some pen and paper because you'll be needing it. Feel free to pause and unpause this video as much as you like and rewind it. And I hope you enjoy and get a flavour of what our lessons could be like in Year 12.
Hello potential Year 12 mathematicians. At this point you have the chance to do a short taster lesson to give you an idea of some of the things that we would expect you to be able to do and give you a bit of a sense of some of the types of skills we would be developing over the course of the A level. So to start with, you are going to try and find these 8 coordinates using the skills that you have from GCSE. I would suggest you pause this video and then you can take as long as you want over it, and then the answers will appear in just a second. So hopefully you did pause that and took some time over doing this. You should have the values that I have on the right hand side of the page there for each of the coordinates. If there are any that you're not certain about, I'm just about to go through those things. However, if you've got all of them, you feel confident you knew what you were doing, you could probably skip ahead a couple of minutes so that you don't have to watch how we get to each of these coordinates. So there are some coordinates here that you should be able to find straight away without any trouble. So things like G here and E, you can see that they are the y-intercepts of your straight line and your quadratic. So G is the y-intercept of y equals 2x plus 3, so 0, 3, because of that plus 3 there. And then for your point E, we know that we are looking at the y-intercept of the quadratic, so 0, negative 12, because of the negative 12 being the constant. And then from there, let's look at point C. So point C is the point where your linear graph cuts the x-axis, and you know that anywhere along the x-axis, the y value is 0. So if we put 0 here, if we said 0 equals 2x plus 3 and solved that, we would get negative 3 over 2, or negative 1.5. Then, moving on from there, I would start to think about maybe A and D. So A and D are the x-intercepts of your quadratic. So if we look at your quadratic, you have x squared, add 4x, minus 12. If we set that equal to 0 to find those x-intercepts, If we factorise that, we'll have x plus 6, x minus 2, and so that gives us negative 6 and 2 as our x values. And we can see that D is the coordinate that's got a positive x value, so that will be the one that's 2, 0, and A will be the negative 6, 0. So making good progress here. The other points that we can focus on next are maybe B and F. So if we look at B and F, we can see that they are the points of intersection of your linear function and your quadratic. So if we say x squared plus 4x minus 12 is equal to 2x plus 3, subtract the 2x, subtract the 3, so that we've got a quadratic equal to 0. Then we can factorise this to get x plus 5 and x minus 3. And then we know that that gives us x coordinates of negative 5 and 3. If we look at those 2 points, B and F, B is the one with the negative x coordinate, so that will be negative 5. And F is the one with the positive x coordinate, so we'll have 3. And then we can find our y values by substituting into either of these 2 functions. I would probably substitute into the linear one just because it is more straightforward. So when x is negative 5, we will end up with negative 7. And when x is 3 and we substitute into 2x plus 3, we'll end up with 9. And your last point is that point H at the bottom. And you should remember from GCSE that you can find the minimum point of a quadratic by completing the square. So if we have x squared plus 4x minus 12, and we complete the square, we'll have x plus 2 squared minus 4 minus 12. That gives us x plus 2 squared minus 16, which means we have negative 2 as our x coordinate and negative 16 as our y coordinate. So that should be familiar to you from GCSE, and this gives you all the same values as we had slightly earlier on in the video. Moving on to the sort of main task in this lesson then, we are going to be focusing on an investigation that uses sequences in some capacity. So your first job is to try and find the nth term of each of these sequences, and if you don't want me to ruin that for you, you should definitely pause the video now and do that. We're going to say that the dots that are there shouldn't be there. So the first term of the first sequence is 1, the first term of the second sequence is negative 16, etc. So pause this video if you don't want to see the answers. So let's do those answers now. So for the first one, you should see that your sequence is an arithmetic sequence. So you might have heard it called a linear sequence, where it goes up by the same amount every time. You can see it increases by 2, so it'll be 2n and then minus 1 to get the correct terms. The second one, you can see that your sequence is increasing by 11 every time. So we'll have 11n, and then we'll have to take away 27. And then for our third one, we can see it's decreasing by 2 every time, so negative 2n, and then we'll have to add 80. So now that we have recapped how to find the nth term of a sequence, that should lead nicely into the next little bit of the lesson where we do a bit of an investigation. So here you can see that you have got the setup for 2 simultaneous equations, and you're going to pick 6 consecutive terms from any arithmetic sequence and place them in order into the squares below. So as an example, I might say, let's have a sequence where my first term is 4 and it increases by 2 every time, so 4, 6, 8, 10, 12, 14, so that I've got 6 consecutive terms of a sequence, and then I'm going to put them in order, so I'd say 4, 6, 12, 14. And once you've chosen a sequence and you've got your 6 terms in there, so any arithmetic sequence you want, you're going to solve that pair of simultaneous equations. So you should find that you get an x value and a y value. And that again would be something that we would expect you to be able to do from GCSE. So you're going to do this a few times for a few different sequences, set up your simultaneous equations and find your solutions and see if you discover anything. Once you've done a few, you should spot what's happening pretty quickly. Can you make any kind of conjecture, any kind of discoveries about what's going on, and then could you potentially try and prove it? So again, I would pause this video at this point, set yourself up a pair of simultaneous equations with your 6 terms of any sequence, maybe do it again and see if you can spot what is happening. So I have decided for my example to do that I'm going to pick a much nicer, more straightforward arithmetic sequence and just go with the first term of 1 and a difference of 1. So I've got 1, 2, 3, 4, 5 and 6. And that means my simultaneous equations are x plus 2y equals 3, and then 4x plus 5y equals 6. And then if I solve those as a pair, so I think I'm going to eliminate x by multiplying that top equation by 4. So I'll have 4x plus 8y equals 12, and then I've got 4x plus 5y equals 6. And then if I subtract that second equation from the one at the top, we can see that I'll have 3y is equal to 6 and y equals 2. And then we should remember again from GCSE that we can substitute that y value back into either of the first 2 equations. So if I chose x plus 2y equals 3, I would then have x plus 4 equals 3 and x is negative 1. So I end up with my pair of solutions as x equals minus 1 and y equals 2. And hopefully if you have either done that same example as me, just to make your life easier with the numbers, or if you've done different examples, you will have also found that x is negative 1 and y equals 2. So hopefully now that you've drawn that conclusion, you've maybe started to think about how you could prove it. And this is a big part of the A-level course, is proof and trying to be persuasive in your written work and what you're showing. So we're going to look at how we could prove that our solutions would always come out to be x equals negative 1 and y equals 2 in the next little part of this video. So if I want to prove what we have discovered, it is not going to be enough for me to just show that it's true for a few sequences. I'm going to need to think about every single possible sequence. And so to do that, we start off by having a first term of a. So that can just be any number that is the first term of our sequence. And then because an arithmetic or a linear sequence always increases or decreases by the same amount, we call that a common difference. And so we say our second term is a plus d. And d could be positive or negative, but that's fine. We'll have a and a plus d. And then if I wanted my third term, then I would have to add d on again. So hopefully you can see that that would give me a plus 2 lots of d, because I've had my first term, I've added d once, I've added it again, and then you can see your 4th, 5th and 6th terms here. And then I'm going to put that into my setup for my simultaneous equation. So that means that I will have ax plus a plus d y equals a plus 2d. And then when we set up our second equation, we'll have a plus 3d x plus a plus 4d y equals a plus 5d. And at this point it might not be that clear what we can do next, but if we have a little look at our 2 equations, if we look here where my pointer is, if I expand that bracket, I'll have ax plus 3dx. And you can see you've also got an ax in that first equation. So actually if we subtract that first equation from the second equation, then there will be lots of nice things that happen and we'll get lots of nice simplifying. So if we expand our second equation, as we said, we'll have ax plus 3dx, then we'll have plus ay plus 4dy, and that is equal to a plus 5d. And then if we expand that first equation, the ax term is the same, then we'll have ay plus dy, and that is equal to a plus 2d. So I now have to subtract that bottom row, that second equation, from the one on the top. So if I do a plus 5d, take away a plus 2d on the right hand side first of all, that's going to leave me with 3d. And on the left hand side, the ax take away ax will obviously disappear, as will ay take away ay. And then what we have is 3dx from the top equation, add 4dy, take away dy from the equation that's on that second row. So if I simplify, I'll have 3dx plus 3dy equals 3d. And we can see that every single term in that equation is currently being multiplied by 3d. So if we divide through completely by 3d, we'll have x plus y equals 1. And actually, if we just make y the subject of that, we'll have y equals 1 minus x, which is going to be useful in just a second. So at this point in our proof, we can go back to that very first equation, which I'm just about to highlight, so this one here. And now that we know that y is equal to 1 minus x, we can replace y with 1 minus x in that equation, and lots of nice things will happen. So if I rewrite that equation, ax plus a plus d y equals a plus 2d, and I replace y with 1 minus x, I will have ax plus a plus d 1 minus x equals a plus 2d. And from here we can just expand and do lots of simplifying as you would normally do. So firstly, we obviously need to expand those two brackets however you would normally do that. So I'll have ax, and when I expand these brackets I'll have a plus d minus ax minus dx. It's still equal to a plus 2d on the right hand side. And then we can simplify some of that left hand side. So ax take away ax, that will cancel. I can also subtract a from both sides, so that a will be gone, as will that one. And that leaves me with d minus dx being equal to 2d. And as with that other equation where we divided through by 3d, here we can divide through completely by d to give us 1 minus x equals 2. And actually, if we then make x the subject of that, we will get x equals -1, which we shouldn't be surprised by because we've already seen that x is always going to be -1 from the examples that we've done. And at that point, all that's left is finding y. We know that y is equal to 1 minus x, so we'll say y is equal to 1 minus our x value of -1, and that means that y is 2. And so we have proved that that is the case for every single pair of simultaneous equations of that form. So hopefully you've managed to achieve quite well with the simultaneous equations part of that, and you've been able to follow that proof. And proof is something that we build up to over the course of the A level, as I said. So thank you very much for taking part in the maths induction lesson, and I hope you enjoyed it.
Okay, so that is bringing us towards the end of our video, and I really hope that you did enjoy that lesson that Miss Watson has just done for you. Please don't panic too much if you got a bit lost or couldn't see the start of her proof towards the end. Focus on the skills that you used. So in the start, we looked at that graph of all the quadratics, and you used like factorising, pleasing the square, which are all really key things that you'll need at A level. And then you looked at finding the nth term of a sequence and solving simultaneous equations. I hope you were all able to do that because they are key skills. And the whole point of that task was to look at how we take a topic from GCSE, such as simultaneous equations and linear sequences, and expand and develop it at A-level into the realm of proof. Now, proof is an important part of A-level, but we don't expect you to be able to do those types of proof from the off, which is why Miss Watson guided you through it really carefully. We do a lot of work with you on structuring proof and developing your proof skills. So I really don't want you to be put off if you find that looks really complicated. They will do a lot of work to build and develop you. We just want you to see what it could be like and how your skills will be developed. So I hope this whole video and lesson has informed you about what maths is like at Herts and Essex, what you could get out of it. I really, really look forward to hopefully meeting and seeing you in September. We'll have a great 2 years ahead of us. Please do fill out the Google form. If you have any questions or any queries about anything, please do get in touch. No question is too silly. In the meantime, until September, I wish you well, safe and healthy. Please take care. Have a great summer. I'll see you and meet you in September.